Hi everyone, I welcome you all in the quick solution discussion of All India Akash Test Series Medical 2019. And I'm here with the test number 11, code A and B. Let us begin with the chemistry section of this paper. Select the incorrect statement among the following. First we have first option, that is ZNO, is white at room temperature but turns yellow on heating. If I talk about ZNO, it has non-stoichiometric defect. Basically that defect is known as metal excess defect. In that case there is extra cation at interstitial site and that results in the change in color of zinc, while if you heat it, it becomes yellow, and that's why this is correct. Further, density of crystal remains same in Frankel defect. If I talk about Frankel defect, yes, density remains same, that's why this is also correct. Further, the appearance of the color in solid alkali metal halide is generally due to F center. This statement is also correct. And further, if I talk about FeO, in this case, the proportion of iron is 0.93 while the proportion of oxygen is 1. That compound has stoichiometric defect. No, it's a kind of non-stoichiometric defect. This is non-stoichiometric defect. And if it is so, it means this statement is the wrong statement and our correct option is option 4. After this, I have the next question. Question number 47. The EMF of the cell. We have the cell in which copper is getting oxidized to form Cu2 plus ion. The solution has the concentration that is 1 molar. Further, we have the salt bridge here. Further, Ag plus ions are getting reduced to silver and the concentration of the silver ion is 0.1 molar. That is X volt. It means EMF of the cell is given, that is X volt. Now what you did, when the concentration of the anode and the cathode are interchanged, it means you are taking the concentration. Initially copper ion concentration was 1 molar and silver ion concentration was 0.1 molar. Now you have changed the concentration. These are basically interchanged. Then the EMF becomes Y volt. Select the correct option among the following. We'll understand this question with the help of Nernst equation. What's that? We know that E cell is equal to E naught cell minus 0.0591 divided by N log QC. And here we are taking log on the base of 10. So, what would be the value of E cell? The value of E cell for the first case is already given. That value is X volt and this is equal to E naught cell minus 0.0591 divided by N. What would be the number of electrons which are transferred in this case? Just have a look on this equation. Cell reaction is given here. The cell is given here and this is 2. Further, what would be log QC? In this case, QC we can find out with the help of the given cell reaction. Cell reaction indicate that in this case, I'll write here the cell reaction to understand this concept better. We have Cu. These are gaining. Silver ion is there. Silver metal would be formed. Cu2 plus ions are formed. And in this case, there is the charge should also be balanced in this case. This way. This is the reaction. Now, the concentration of the product we place here as the numerator. So, for the copper ion, it is 1. And for the silver ion, it would be 0.1 raised to the power 2. And if you solve this, you will find E naught cell minus 0.0591 by 2 into 2 log 10. And this can simplify it minus 0.0591. This is the value of X. I'll just mark it. This would be the value. Now, for the value of Y, Y is the value of E cell when you reverse the concentration of cathode and anode. It means in this case, this Y would be equal to E naught cell minus 0.0591 divided by 2 log Concentration of the product now becomes 0.1 raised to the power 2 divided by 1. So it can simply be written as, here I am using it, y is equal to E naught cell plus 0.0591 by 2. This would be the expression. So in this case, if you compare x and y, you will clearly understand that x is less than y is more, because y is E naught cell plus 0.591 by 2, while if I talk about x, that value is E naught cell minus 0.591. It means we have the correct expression about x and y here, that is x is less than y. On that basis, option 2 becomes the correct option, and the answer for your question also becomes option 2. After that, now question number 48, mechanism of a hypothetical reaction. The reaction is here, 2A3 is giving you 3A2 is given below. The mechanism is given, 2 steps are there. In the first step, A3 is getting changed into A2 plus A. It means equilibrium is there. In this case, we can apply equilibrium constant. Now, second reaction, in which this is the fast step where A3 is combining with A to give you 2A2. This is a slow step. It means this is mainly the rate determining step also. The overall order of the reaction will be the very first thing. If you concentrate on the first step, that's the fast step, here is an equilibrium between the concentration of A3, A2 and A. So the K equilibrium for this case would becomes the concentration of A2 and the concentration of A divided by the active mass of A. So on the basis of this, if you find out the concentration of A, that would be equal to K equilibrium into the concentration of A3 divided by the concentration of A2. This would be, say this equation becomes number 1. Now, if I talk about the second reaction in which A3 is combining with A to give you A2. In this particular case, as this is the slow step, definitely it will decide the rate also. So rate of this reaction would be directly proportional to the concentration of A3 and the concentration of A. Now in this expression, if you place the value of A, the value of A in terms of equilibrium constant would becomes the product of A3 by A2 into K equilibrium. This expression we have this way. Now let's simplify it. Rate of this reaction will become directly proportional to A3 raised to the power 2 and A2 raised to the power minus 1. So this would be the final expression for the rate of particular reaction that's given here, and on that basis we will choose here the overall order of the reaction. What is the order of the reaction? That is the sum of the parts of the reactants in the rate expression. So here is 2 and this is minus 1. 2 plus minus 1, it becomes 1 only. That's given here in option 3. So your correct answer becomes option 3. After that, question number 49. Which of the following does not form micelle in aqueous solution? We have different options. Pyridinium chloride, the first option, cetyl methyl ammonium bromide, sodium stearate, and dodecyl trimethyl ammonium chloride. We know that for the formation of micelles, there should be large sized ion with high molecular mass. Along with that, some hydrophobic tail should be there, hydrophilic head should be there, because if we're talking about iron, definitely hydrophilic head would be there, hydrophobic tail should also be there. So in this case, if I talk about option 1, if you look at the structure of pyridinium chloride, you will see that it does not contain iron with high molecular mass. That's why it is not able to form micelle, while the other 3 species are doing so. That's why the answer for this particular question becomes option 1. That's correct. Question number 50 we have. A reaction can never be spontaneous if, first of all, we should know the condition for spontaneity, delta G value. that should be negative. And we know that delta G depends on enthalpy change T delta S. Now in this case, if the value of this delta H is positive and the value of delta S is negative, then at any temperature this reaction will not be spontaneous. Always you will get the value of delta G as positive. Positive means non-spontaneous. So this reaction can never be spontaneous if delta H is positive, delta S is negative. Where this is given, we have to analyze the given options. On the basis of this, we will see that this delta H is more than 0 while delta S is less than 0. Where this combination is given. This combination is correctly given here in option 3. So the correct answer becomes option 3. After this, so the correct answer for this question becomes option 3. Now after this we have the next question.